In this episode of Remote Trigonometry, we will be going over the idea of an identity. An identity is a statement that is true for all possible defined values. Some common identities include the definitions of tangent and cotangent and secant and cosecant. Tangent, for example, is equivalent to sine divided by cosine. So that means that for every value of x, tangent of x is going to be the same value as sine of x divided by cosine of x. That's an example of an identity. Another identity that might be less familiar is the square root of tangent squared of 2x plus 1 is equivalent to the absolute value of secant of 2x. That means no matter what value of x you plug in, the expression on the right is going to equal the expression on the left. And then a very common important identity, actually given a name called the Pythagorean identity, is that cosine squared plus sine squared is always equal to 1. And really, that's just the equation of the unit circle. X is the adjacent side of this right triangle, y is the opposite side of this right triangle, and 1 is the hypotenuse. And so if you square x and you square y and you add them together, you should get the square of the hypotenuse, which would always equal 1. And cosine is defined to be x, and sine is defined to be y. So cosine squared plus sine squared should also always equal 1. So that's a very important identity that we will run across a lot. Some of the less familiar identities, a good way to test them is to check a graphing calculator or Desmos or Excel, some computer program that will calculate things for you. And so, for example, I have a graphing calculator here, and I'm going to type in tangent of 2x squared plus 1, and I put that underneath the square root. And then on another y equals, I'm going to put secant of 2x, but we're taking the absolute value, so I'm going to go into the catalog and find absolute value. And then secant, another identity, is that it's 1 divided by cosine. So that's how I'm going to program the calculator. And so here we have 1 divided by cosine. And hang on, let's count our parentheses. 1, 2, 3, 4, 5. Too many parentheses. There we go. So it's an identity, if that's true, for every value of x. So let's just randomly go into the table and see what the table gives us. Hey, look, y1 is giving us the same values as y2, no matter what value I'm plugging in. So that's not an official theoretical proof, but it's a good illustration that an expression is an identity. It would be an odd coincidence if every one of these values gave the exact same number if that wasn't really an identity.